so welcome to Dividing Polynomials Part 3. All right, so we'll come back at the end if you guys have any questions. I should have some time to look over your homework, and then we can go back and look at it, but hopefully we'll clear up any concerns. Okay, so if you'd like to at this time, go ahead and take out your notebook, and if you want to copy these notes, go for it. Pause this. I'm going to give you guys 2 minutes. 2 minutes to copy down these notes. If you can't finish it, then you need to go on School Loop and finish copying them down. Or you can take a picture of it before I go to the next slide. Or at the very end, I can come back to it, but I don't know if we'll have time. 1. Okay, I'm not going to go over these steps right now because I'm going to be going over them as I do the process, because I don't think they make a lot of sense until you see what I'm doing with them. Okay? All right, so this is the graph. Oh, too bad Aaron's not here because he asked this question. Or maybe it was Kane. So when I have no remainder, I have just 2 factors, right? And when I solve for 0, I get 2 zeros. And that's my graph there. If I were to multiply them out or FOIL them, I would get the equation in standard form, and then that gives me my y-intercept. So lots of things you've learned, right? Okay. When I do get a remainder, what happens is we end up with imaginary zeros. Okay? That means it wasn't factorable. Okay, Mom, I don't want you writing. I don't want anybody writing pencils down. If I see anybody with a pencil right now, I'm going to take it away. Okay? All right. All right, so students will be able to divide polynomials using long division and synthetic division. We're going to do both today, side by side. Okay. So if you have a remainder of 0, means you know how it factors. If it's only a trinomial, we don't need to divide, right? Because we could just factor it. Remainder other than 0 means we do not have a factor. And that's kind of what we're going to look at today. So if we have a 0, we know it's a factor. If it doesn't end in 0, then we don't have a factor. And I really wish I hadn't even shown you this yet. I'll come back to the slide. It'll make more sense after we do this. For instance, let's look at these 2. So I have 2x cubed minus 7x squared plus no x plus 5. And I'm dividing it by x minus 3. Don't even look at the rest of this. Let's just cover this up, and let's just cover this up. Take a look at both of those. Actually, I think I'll bring this up. And compare and contrast those 2 for a second there. The highlighting of the 2 should give you some clues. What did you guys find? I don't hear any talking. Let's hear some talking. Talk amongst yourselves. Okay, in 5, 4, 3, 2, 1. Who has some comparisons? Let's hear it. What? The yellow changed the signs. That's a difference, right? So that's not a similarity, that's a difference. So let's go and let's talk about it. Why do you think that is? First of all, it's the same division problem. Did you guys notice that? Okay, so this 2x cubed, all I'm using is the coefficient. Let me change this. So this 2x cubed, all I'm using is the coefficient here. This negative 7x squared, all I'm using is the coefficient of negative 7. This is 0 x's, so I put 0. And this is a 5, so I put a 5. But right here, it says x minus 3, and this is 3. So actually, the 0 of x minus 3 is 3. And you're going to notice when we do synthetic division, we never draw the line and change the sign. And the reason is that we already changed the sign. Right? In the very beginning, we already changed the sign. Does that make sense? Okay. All right, so let's do one. Leave that there. Oh, I forgot to take that out. Okay. So let's just set up synthetic division to begin with. So I'm going to do the first two for you, and then we're going to get whiteboards out, and we're going to do the other ones, because that is probably the most crucial part. Let's do blue. All right, so everybody paying attention? So if I have x plus 2, my 0 of x plus 2, when I set it equal to 0, is negative 2. Then my coefficient is 2. First, I'm going to ask myself, are there any holes? I have x squared, 2, 1, none. So I'm good. I don't have any holes. So I bring down a 2, bring down the 7, bring down the 9. You do this one, x plus 1. The 0 of x plus 1 is negative 1. I have 3, 2, 1, none. So I'm good. I don't have any holes. So the coefficient of x cubed is 1. The coefficient of 3x squared is 3. This coefficient is 3. This coefficient is 1. Kane, what's your question? There's lots of different ways to draw it. I think Ms. Liz made this presentation last year, and that's just the way she did it. And in the presentation, I want to stay consistent, but with the way I would do this one normally, I don't know why it makes me so comfortable, is I would do it this way. It's just like, it doesn't mean anything. It's just like the division sign. It's a way of separating this number from this number. It has nothing to do with the symbol at all. It's just, there's lots of different, you'll see it written a bunch of different ways. If you want to just do a line like right here, even though I think that looks like a 1, right? So it's kind of just whatever you want to do. Yes, Mama? We'll get there. I don't want to get ahead of ourselves. This is all we're doing right now. So you can either write it like this. So how about, you could draw a squiggly line if you want. So this is negative 1. So I'll draw it both ways. Whichever way you guys want to set it up. It just means this is my 0, and these are my coefficients. This is my 0, and these are my coefficients. So why don't you guys go ahead and do this one on your whiteboard. You're just setting it up. That's it. I want to see you guys setting it up. I'm going to go ahead and pause the recording. Okay, so if I reset this one up, the only mistake I saw, you guys, I'm talking now, right? We're not doing too well today. All right, so the only mistake I saw is there is a 0 in here, right? There is a hole. So my factor, this is my factor. My 0 is negative 3. My coefficients are 4, 3, 2, I don't have an x to the 1. So I need to put in a place marker for that one. I need to put in a 0 over there. So 3, 2, 1, none. Now we're good. So I have a 4, a negative 6, a 0, and a negative 3. Essence. It doesn't matter if 0 can be positive or negative, it's still 0. Yes. Wait, I can't hear what you're saying. Chris, thank you. I still don't understand what you're saying. Oh. Yes, it has to be x. Well, there is an exception, and we're going to talk about it. Okay? But yeah, that's when it works best for synthetic. Yes. If I say 1,000, If I write this number, does it matter if I write it like this? Yes. You guys need to start using structure for that, right? Just think about it in terms of numbers. If it wouldn't work for numbers, why would you do it with algebra, right? Because algebra is just an extension of our numbers. So just think of it that way when you have questions like that. Okay? Good question. Remember, that's kind of why we need the place markers. If I had 1003, I wouldn't write it 13. You know what I mean? Okay. All right, I don't think we need to do another one. I think we're pretty good. Let's move on. All righty. Can you find the error? Talk to your table group really quick. So two students use synthetic division to divide 3x cubed minus 2x minus 8 by x minus 2. Determine which solution is correct. Find the error in the other solution. Okay, let's call this 1 and let's call this 2. With your fingers, show me which one has the error. Show me which one has the error. Okay, not everybody's participating. Again, we're almost at 100%. If my factor is x minus 2, when I find the 0, it's x equals 2. So this one's correct. This one has the error. Okay? Alrighty. Alright, so now I'm going to do one. Okay, so still no need to be writing. Go ahead and cap those markers for me, please. So first I'm going to see if I have any holes. 2, 1, none. No holes. My 0 is positive 3. So 3, my coefficient that I'm going to use for long division, is my first one is 1, negative 5, and 6. So here's how we do this. I'm going to draw a line. And my first step is I'm going to, so first in my synthetic, in descending order, fill in the missing terms for 0. I didn't have any missing terms. Divisor must be 1x minus a, where a is any number. That's what we did here. We found our 0. Finding our 0. We're not going to talk about this step yet. This is what I just did, step number 3. I just set it up. Step number 4. This is where we start doing our synthetic division. Joey, I need you looking up here so you can do this. Joey. Bring first coefficient down. I'm just going to bring the 1 down. 5. Multiply, add down, and repeat. So I take my 3. I'm going to multiply it by my 1, and I get 3. Now I'm going to add these two together. Negative 5 plus 3 is negative 2. 3 times negative 2 is negative 6. When I combine 6 and negative 6, I get 0. Since I got a 0, I know that 3 is in fact a 0. Okay, it is one of my zeros for my graph. If I don't get a remainder, if I do get a remainder, then this is not a 0. And that's what we're going to talk about yesterday. We're going to be trying to use synthetic division to find zeros. But today, we don't have to worry about that. Okay, I'm going to do another one. I just wanted to tell you there's a purpose for what we're doing, okay? I'm building upon it. So tomorrow we're going to extend it, okay? Jay, I need you to sit up, please. Okay, so I'm going to do it again. If I were to just factor this, right, it would be x, and 6 is 2 and 3, correct? And both of them are negative. So x minus 3 is a factor, and the other factor is x minus 2. So my two zeros are x equals 3 and x equals 2. And some of you might ask me, why didn't you just factor in the beginning? Well, I'm showing you something simple, right, on something you already know how to do, so that when we do the hard ones, you can do the hard ones. Because normally, no, I would not use synthetic division for this problem. Right? I'd just factor it. It'd be much faster. But we're not going to be dealing with trinomials. We're going to be dealing with polynomials. Okay? And you can't factor polynomials unless, when can I factor polynomials? When there's 4 terms. Not not completing the square. There's only one time when I can factor. Okay. Can anybody tell me, for a piece of candy, when can you factor a polynomial with 4 terms? No. Irene? I'm going to give you GCF. No, because you'd still have 4. You'd still have 4. Nope. There's certain factoring methods we can use when we have a polynomial with 4 terms. No. Kane? Nope. All right. Too bad. Mrs. Muller gets it. Yeah, I'm going to tell you. I'm just not going to give out any candy. Factor by grouping is when you have 4 terms, right? You did that. Okay. All right, so I'm going to do one more, and I'm going to let you copy this one into your notes, okay? So x minus 3, my 0 is 3. So I'm going to put a 3 here. Make sure I don't have any holes. 2, 1, none. I don't have any holes. My coefficients are 1, negative 7, and 10. My first step is to bring down that 1. 3 times 1 is 3. Negative 7 and 3 is negative 4. 3 times negative 4 is negative 12. Negative 12. Negative 12 and 10 is negative 2. What does this tell me? This 3 is not one of my zeros. Okay, that's all that it's telling me right now. So that's all we're doing. Is 3 a 0 or is 3 not a 0? If you have a remainder, it's not, right? If you get a 0, you know it's one of the zeros. Yes, King? At the end, I wanted you to leave it like this. Is good. This is perfect. What you're going to be doing in your homework is I think you're doing side by side. The long division and the synthetic, and you should get the same out. You should get the same remainder. Yeah. You're probably thinking of some, we did change the sign here. It was minus 3, and we made it positive 3. We're not going to talk about possible zeros until next week. Okay? Alrighty. You're just jumping a little bit ahead for me. All right, so why don't let's do this. Why don't you guys set this one up for me? Then I'm going to have you do it, and then you can copy it down your notes once you know you've done it correctly. Okay? So try this one on your whiteboard. I said first you're going to show me the coefficients, and then we're going to solve. Okay, so let's set this up. We're not doing long division yet. I'll come back and I'll do that on the last one. Okay, so the first thing I need to do is ask myself, what's my 0? My 0 is x equals 5. So I have a 5. And then my coefficients are 2, 1, none. I have no holes. So 1, 8, negative 3. So make sure you have that. Now go ahead and solve it. Not solve it. Find your quotient. That's what we're finding, right? We've got a dividend with a divisor, and we're trying to find the quotient. The answer to a division problem is your quotient. Okay, so I'm going to go ahead and finish this one up. So I'm going to bring down the 1. 5 times 1 is 5. 8 and 5 are 13. 5 times 13 is what? Well, I know 5 times 3 is 15, right? And 5 times 5 times 1 is 5, plus that 1 is 65. 65 minus 3 is 62. Tells me that 5 is not one of my zeros. Because I have a remainder. Remember back to the very first screen? Hold on, I'll show it to you in just one second. Right here. Here's your visual. See here, this is no remainder. So now we have zeros. Right? Remainder, no zeros. Okay? When you have remainders, you don't have zeros. It's testing to see if it's a 0. Okay, so I'll let me pass out your homework, and you can copy that one down in your homework and in your notes if you'd like, so I'll go ahead and pause it. Is it pause? Okay, it's go ahead and it's recording. Okay, so this was a really good question. When you guys, this is the synthetic division. Let's get rid of this, and I'll do the long division. Go ahead and cover that up. So the long division would be x squared. Let's bring this down a little bit. X squared plus 8x minus 3, x minus 5. So x goes in x squared one time, right? Or 1x's. So x, I should change my color. So 1x. X times negative 5 is negative 5x. X times x is x squared. Draw the line and change my sign. I bring down 8 plus 5 is 13x minus 3. X goes into x squared 13 times. 13 times negative 5 is negative 65, we said? Right? Negative 65, and 13 times x is 13x. Draw the line and change the sign, and we get 62. Okay, notice the comparisons. This is a remainder of 62, or 62, I should say, plus 62 out of, this is how you're going to see it on the CAS testing, over x minus 5. So it's x plus 13. This answer, plus 62 out of x minus 5. Look over here. This is also your quotient, right? If this is my ones place, isn't that my constant? Just like this is my ones place and that's my constant? So what's this? My tens place, right? What normally goes with the tens place? X. You're getting the same answer, only on the synthetic division you get it at the bottom. And with long division you get it on top. So I would rewrite this as x plus 13 with a remainder, x plus 13 with a remainder of 62 out of x minus 5, because that was my original factor. This one is definitely easier, but we can't use it all the time. Yes, I'm sorry, Jean. Yes, that is your answer. You should get the same answer. We're going to talk about that right now. As soon as you guys are finished copying this down. Yes. The check is multiplication. Yeah, the box. Yeah, you should be able to multiply x minus 5 times x plus 13, and then add 62, and you should get the original dividend. Yes. I can't hear you. I'm going to show you right now. Yes. I wouldn't go right now. This wouldn't be a smart time to go. All right, one more minute to copy this down, and then I'm going to do number 3 with you. 2, 1. Okay, so I'm going to go ahead and skip over number 2. You guys can totally do that. Instead of 3 terms, you now have 4 terms, right? So you're going to do that long division and synthetic division. This is the only one, and I'm going to do it for you, that I would choose to do it with long division instead of synthetic division. Okay? And this is why. I can't have a 2 in front of that x. So I have to divide everybody by 2. I can't just do this, divide this by 2. I've got to divide everything by 2. Because my 0, if you think about it, 2x minus 1, 2x equals 1. My 0 is 1/2. I have a 1/2 for a 0. Hold on. Okay. So if I divide everybody by 2, look what happens. Divide by 2, 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 divide by 2. Everybody gets divided by 2. Does this look like it's going to be a lot of fun to do? It's possible, and I'm going to show you right now that it's possible, but this is why you have an option on the backside to pick which one you want to do. If it's got a coefficient, you can go ahead and use long division. If it doesn't have a coefficient, synthetic is your better choice. I'm just going to go through this, and I'll come back to you, Kane. Okay, so when I divide everybody by 2, this becomes x minus 1/2, right? So when I take the opposite of that, or solve for 0, x is equal to positive 1/2. So here's 1/2. Let's look at my factors. 4 divided by 2 is 2. Negative 3 divided by 2 is negative 3/2. Positive 7/2. And 2 over 2 is 1. If you're a person that's not worried about using fractions, you'll be fine with this. So I'll go ahead and I'll bring down my 2. Nobody should be writing right now. Bring down the 2. What is half of 2? 1, right? But I'm going to write it in fraction form. How do I turn 1 to have a denominator of 2? 2 over 2, right? 2 over 2 is 1. Because I'm dealing fractions, I might as well keep it in fraction form. If you're like going, whoa, it's okay. You don't have to do this, okay? You can copy my example and then use long division for anything that's got a coefficient. So 1/2 of 2 is 1, but I'm going to write it as 2 over 2. 2/2 minus 3/2 is negative 1/2. Half times a negative half is negative 1/4, right? So I'm going to leave it negative 1/4. I'm going to change this to fourths. How can I change this to fourths? Multiply the numerator and denominator by 2. So I have 14/4. Isn't this so much fun? So 14 minus 1 is 13/4. 1/2 times 13/4, I'll do the work down here. 1/2 times 13/4, right? Well, I do, but that's a little bit difficult. Synthetic is all done in your head, right? We're not supposed to be writing right now, Bryce. Just supposed to be watching. So I have 13 over 8, correct? 1/2 times 13/4 is 13/8. Turn this into 8. 8 plus 13 is how much? 21? So I have 21/8, and that's my remainder. Well, I knew you wouldn't like it. That's my whole point. Did I make a mistake? Okay, Kane, let's answer your question, and then we'll move on. No. No. You mean you have to use a coefficient? You have to make it a coefficient. It doesn't work if it's not a coefficient of 1. But if you wanted to, you didn't have to divide everything by 2. You could have, at the very end, divided all of these by 2. You can do it both ways. But you have to begin with this being a 0. I wouldn't want you to. No. I guess it really doesn't matter. All right, let's see if I made any mistakes. I'm going to do it in long division, and then I should find out if I have any mistakes, right? All right, so 2x minus 1. If I wanted to get rid of all of these fractions, couldn't I multiply everybody by 8? Right? As long as I do it to everybody, right? So 8 times 2 is 16. I'm not sure if this is going to work. This would be negative 4, right? This would be 2 times 13 is 26. with the remainder of 21. I'm not sure if this is going to work. I haven't done this in a while. Let's look. All right, so 4x to the fourth minus 3x squared. 4, 3. That's why it looks like this. Gosh darn it. Ugh. I was wondering why I put in such a hard problem. Oh, relax. It won't take me. No, we're not crossing it out. Okay, so I have a 2. My 0 is here, right? That's why I have those crazy fractions. 4, 3, 2, 1, none. Out of all the ones, right? 3 halves, 7 halves, and 1. Let's see if this goes easier. The 2, 1 half times 2 is 1, right? 2 halves, if you have 2 halves, you have a whole. That's 1. 0 plus 1 is 1. Half of 1 is a half. 3 halves, negative 3 halves and 1 half is what? 3 minus 1, negative 2 halves. Isn't negative 2 halves? Right? Negative 1. Half of negative 1 is negative 1 half. 7 minus 1 is 6 halves, which is, we'll just call it 6 halves, 3. 1 half times 3 is 3 halves. 3 halves plus 1 is 5 halves. Did I mess up again? No? Okay. All right, so we should get this answer, right? Okay. So 2x goes into 4x squared how many times? 2x squared. You've been doing your homework, huh? I can tell. I'll finish this problem for you guys and I'll be online. Because you're having that much fun, Bryce. It's as you get older. All right, you guys, have a good day. Okay, so I finished up this problem, and let's compare and contrast the two side by side. So we ended up with 2, 1, negative 1, and 3 here, which would be, this would be my constant. This would be my tenths place. This would be my ones place. And this would be, ones, tens, hundredths, thousandths. This should be a squared, and this should be a cubed. But then we have a remainder of 5 halves. Let's see how this matches over here. We've got a 2x cubed plus an x squared minus x plus 3. So that matches exactly what we have here. Let me change the color of that. So here's my quotient. Here's my quotient. Here's my remainder. Here's my remainder, but my remainder is being divided by 2 here. But remember, in the very beginning, we divided our everything by 2. So I must divide that remainder by 2. So we have the same answer. All right, that's it for this lesson.